So for example, when I say HNO3, you have to understand that HNO3 is a very strong oxidizing agent. Is a very strong oxidizing agent. And same is the case with H2SO4 as well. What is H2SO4's nature? H2SO4's nature is also being a very strong oxidizing agent. You understand?
Yeah. Yeah.
So basically, what exactly happens is that when we are talking about HNO3, so HNO3 is going to on heating or on naturally keeping aside also. You are doing nothing, just keeping the HNO3 in a beaker and you are waiting. So realize that from the surroundings only some amount of heat shall be absorbed by HNO3, and that HNO3 will break down. So what does it break down into? It always breaks down into H2O plus NO2 and nascent oxygen. And nascent oxygen. What is nascent oxygen? It is a free oxygen formed during the reaction. It is a free oxygen formed during a reaction. And why is it reactive? It is reactive because oxygen is atomic number 8. Configuration is 2,6, so it needs to complete 2 electrons. So that is why it will react. So whosoever oxygen gets to react with, it will combine with that particular element because free oxygen, you know, it has to perform a particular reaction. So we
Yeah.
have free oxygen during a particular reaction. That free oxygen will combine to with whatever element it comes in contact with. But this is the basic nature of concentrated HNO3. What does concentrated HNO3 work? Concentrated HNO3 on sitting decomposes into what? Decomposes into H2O plus NO2 plus nascent oxygen. Are you understanding?
Yeah.
And it leads to the formation of free oxygen. Same is the case with dilute HNO3 as well. So you have to understand that whether it is dilute HNO3 or whether it is concentrated HNO3, it on absorbing thermal energy from surroundings or absorb in the presence of sunlight or a little bit of heating, it decomposes to form H2O plus NO plus nascent oxygen. So I
Okay.
hope you're
Yeah.
understanding. So this is also, and same is the case with H2SO4. How does H2SO4 work? H2SO4 is like H2SO4 on sitting, concentrated H2SO4 will give me H2O plus SO2 plus nascent oxygen. You understand?
Yeah.
So what exactly is happening? Both the acids, concentrated H2SO4, concentrated HNO3. Concentrated basically means when you have large amount of HNO3 in a same beaker. When you have large amount of HNO3 in the same beaker, that means the amount of water is less. That is what you understand by concentrated. That water is less. Water is less. You understand? And
Yeah.
HNO3 is more. When we talk about dilute HNO3, water is
More.
more and HNO3 is less. That's what we are talking about. That means when we are talking about dilute HNO3, the amount of HNO3 is less. You can say that. When we are talking about dilute
Yeah.
HNO3, that means the amount of HNO3 is less. The amount
Yeah.
of HNO3 is less. Yes or no? And here the amount
Yeah.
of HNO3 is high. Any doubts in this?
No.
Understood or not?
Yeah. Understood.
Right. So this is the concept. So when we are talking about concentrated HNO3 and dilute HNO3, that is one thing. Similarly, in concentrated H2SO4, the same concept that because H2SO4 is very high in quantity here and water is less, so hence it is concentrated H2SO4. You understand?
Okay.
And
Yeah.
dilute H2SO4, definitely it is something, but it is not going to act as an oxidizing agent. So dilute H2SO4 or dilute HCl, they do not act as oxidizing agents. Only the concentrated forms act as oxidizing agents. Do you understand my point?
Yeah.
Okay, that is the concept. So when we are talking about HNO3 is a very, very strong oxidizing agent. But there is a special case of HNO3 in the dilute form as well and in the concentrated form as well. In both the cases, it is going to act as an oxidizing agent. Do you understand my point?
Yeah.
Now, understand how does this exactly work? Just see. When we are talking about the acids, right? Now see. So let's suppose we add carbon with concentrated HNO3. Okay? And we expect the
Yeah.
reaction to happen. You tell me independently, do you understand that HNO3 is giving, while sitting, it is giving H2O, it is giving NO2 and
Yeah.
nascent oxygen. But that nascent oxygen will actually now, see, this is a beaker
Mm,
and concentrated HNO3 we have in this beaker. Yes or no? Concentrated
yeah.
HNO3 we have in this beaker. And there is carbon. And this is the beaker. Lot of HNO3 in this. So basically, HNO3 is sitting and releasing nascent oxygen. And that nascent oxygen, I hope you're understanding, will combine with oxygen, because otherwise, if no carbon would have been there in the beaker, that oxygen would come out in the form of O2 gas, because two oxygen atoms would then combine and form O2 gas. Do you
Yeah.
understand? But since there is carbon in the beaker, so that oxygen will combine with carbon, and hence carbon. And now you know the reactions, right? When carbon combines with oxygen, and HNO3 concentrated releases oxygen in less high quantity, in very high quantity. That means you can assume that the amount of oxygen in the beaker containing concentrated HNO3 is very, very high. So that carbon plus nascent oxygen will do what? That oxygen is atomic number 8, configuration is 2,6. Carbon is atomic number 6, configuration is 2,4. So we learned that, what is this oxygen going to do? Tell me. This oxygen is going to pull electrons, and carbon thereby is going to become +4, and O thereby is going to become -2, because oxygen is a non-metal.
Okay.
Are you understanding?
Yeah.
So when we form the compounds, do you understand we have done these kind of non-metal combination reactions?
Yeah.
So 2 times 1, 2 times 2. So this is going to form CO2. So
Yeah.
instead of oxygen being set free, we will have carbon dioxide as a product. So that is why we say that, carbon is being oxidized to carbon dioxide. You understand? So this is
Yeah.
how we write down the equation. Understood or not?
Yes.
On the similar lines, if we are talking about what? On the similar lines, let's suppose I write down this sulfur plus concentrated HNO3. And then we expect the reaction to take place. So then what do you understand that HNO3 while sitting will release H2O and NO2, concentrated one. And in place of carbon here, we have sulfur.
SO2.
Yes or no?
Yeah. Yeah.
And when we have sulfur here, what is going to happen? You tell me. That nascent oxygen will
SO2 is
combine with what? Sulfur now.
sulfur.
So what is it going to
Yeah.
form? It is either going to form sulfur dioxide or sulfur trioxide, depending upon the amount of oxygen being released. So now 99%, what do we form? We form SO2, or sometimes we also form H2SO4. Why? Because I'll tell you. So sulfur is there, atomic number is 16. So configuration is 286. So there is oxygen here. And that oxygen is going to do what? That oxygen is going to pull electrons. Oxygen is atomic number 8, configuration 2,6. Yes or no?
Yeah.
But oxygen is more electronegative than sulfur.
Yeah.
You understand? So what is going to happen? You tell me that sulfur shall become +6 and O shall become -2. So 2 times 1, 2 times 3. When you crisscross, you will get SO3. So
Yeah.
SO3 shall be formed on oxidation. But you combine SO3 with H2O. So what should be my final product? NO2 shall remain NO2. And SO3 is sulfur trioxide. That will dissolve in water. Do you understand?
Yeah.
So H2.
This is when O2 is in excess, yeah.
Yeah, yeah.
Okay.
So here H2SO4 shall be formed. Yes or no?
Yeah.
So they say that sulfur is getting oxidized to concentrated sulfuric acid. But how is that so? Because initially it was SO3 being formed. So you don't have to
Yeah.
actually cram the equation. It's not about cramming the equations. It's like, you have to understand the equations formation. So similarly, you talk
Yeah.
about if I add chlorine, right, with concentrated HNO3. So how would you actually form? So HNO3 on sitting will give me H2O plus NO2 plus nascent oxygen. That nascent oxygen will combine with chlorine, isn't it?
Yeah.
And when it is going to combine with chlorine, then what is going to happen? You tell me.
Mm,
Chlorine is
will
atomic number
form
17,
17.
287. Oxygen is atomic number 8, configuration 26. Oxygen wants to gain 2 electron. Yes or no?
Yeah.
So oxygen, if it wants to gain 2 electrons, then definitely it is going to pull all the 7 electrons, because there is not just one oxygen atom, there are multiple oxygen atoms that HNO3 is going to
Yeah.
release in the beaker. So one chlorine shall become Cl plus 7, and one oxygen if it gains 2, because the need of oxygen is just 2 electrons. So it is going to become Cl2O7. Yes or no?
Yeah. Yeah.
And because it is Cl2O7, what exactly does that mean? It is going to form what? Cl2O7. Cl2O7 is formed. But your books will not write down Cl2O7. Your books will combine that with oxygen, with water. So when you dissolve any oxide in water, what exactly is being formed? You tell me. Tell me. Tell me. So it is going to be H2 Cl2O8, because H2O plus Cl2O7, isn't it, Ayush?
Yeah.
So when you combine this, you're going to get H2 Cl2O8, and then take out 2 common, so that shall become 2 times HClO4. Are you understanding?
Yeah.
So this is the concept.
Understood.
So rather than writing down, your books will write it down like this: Cl2 plus concentrated HNO3 will give me NO2 gas, nitrogen dioxide, which is a reddish brown gas, and HClO4 shall be formed, which is nothing but perchloric acid. Are you understanding my point?
Yeah. Yeah.
Okay, that is the concept. Understood or not?
Yeah.
We have another reaction. If we have phosphorus plus concentrated HNO3, then what do you think would be formed? So concentrated HNO3 is
H2O.
definitely going to release NO2 plus H2O, correct? And nascent oxygen, right?
Yeah.
And this nascent oxygen will go and combine with phosphorus in the beaker. So you combine now individual atom phosphorus, individual oxygen atom. Oxygen's atomic number is 8, so configuration is 2,6. Phosphorus atomic number is 15, so configuration is 2,8,5, isn't it?
Yeah.
So oxygen is more electronegative. So it is going to force 5 electrons for the phosphorus to leave. So phosphorus shall become P plus 5 and O shall become minus 2. And now when you crisscross, you get P2O5. So basically, on combining with phosphorus, the phosphorus is oxidized to P2O5. Are you understanding?
Yeah.
So now when you
Yes. Yeah.
dissolve P2O5 in water, the only thing that you have to remember with P2O5, what is the valency of phosphorus? 3. So that valency of phosphorus would basically require 3 molecules of water. So combine now. So you have 3 H2O dissolved in P2O5. P2O5 takes little bit more water to dissolve. Do you understand?
Yeah.
So if you combine, you have H6, P2, O5 and O3, O8. So if I take out
Yeah.
2 common from here, so it is going to form H3PO4. So I will say the final product is NO2 plus H3PO4. So your books will say that the nitric acid, the phosphorus is oxidized by concentrated HNO3 to phosphoric acid. You understand my point?
Yeah.
Any doubts in this? Understood? So
Why
this is
is
the
3H2O formed again?
basically, this is called hydrolysis reaction. But hydrolysis reaction is not actually a part of your grade also, and none of the boards also have hydrolysis reaction. But I can explain it to you. It involves a certain amount of orbitals. So the orbital concept is here. If you understand that, I can explain it to you. Because that's really you can't do it right now in grade 10. That's a grade 12 concept, and it actually involves some new terms. So as of now, just remember that with phosphorus oxide only you need 3H2.
Okay.
Okay. But for the others, you need just one H2O, but for only P25, you need 3H2. Do you understand my point? How to remember that?
Yeah.
Okay. So that is a concept. So this is how we have these kind of reactions. Now you can write down the reactions for other acids as well. Like for example, for the same thing, if I say Ki and Ki reacts with concentrated HNO3. So what was this particular reaction, the previous reactions? You tell me. The previous reaction was all non-metals with concentrated HNO3. What did I do? I told you the reaction of carbon with HNO3, right? Chlorine with HNO3, sulfur with HNO3, phosphorus with HNO3. These are all what? These are all non-metals. These are all non-metals with HNO3. But now, for example, if I ask you certain compounds with HNO3, so how does it basically work? Understand? So you must be aware of the polyatomic ions or radicals. Like SO3 minus 2 is nothing but sulfite, right?
Yeah.
NO2 minus 1 is nothing but nitrite. You understand? PO3 minus 1 is nothing, minus 3 is nothing but phosphite. And and when HNO3 decomposes, you know that HNO3 while sitting only by absorbing all the thermal energy, it is going to give you H2O plus NO2 plus nascent oxygen. So that
Yeah.
nascent oxygen, when it combines with the sulfite, it is going to convert into SO4. When that nascent oxygen combines in nitrite, it is going to convert into nitrate, NO3 minus 1. When that nascent oxygen is going to combine in phosphate, it's going to form PO4 minus 3. When that nascent oxygen is going to combine in what? S minus 2. Sometimes this happens that, but here it acts in a different way. Because see, understand, what is the nature of oxygen? To pull electrons.
Mm. Yeah.
To pull electrons, to gain electrons. So you tell me if sulfur is there, sulfur is atomic number 16. So 286. In the valence shell, there are 6 electrons already, normally in the neutral
Yeah.
sulfur, isn't it? In the
Yeah.
neutral sulfur. Yes or no?
Yeah.
And because we are writing down S minus 2, so that means 2 extra red electrons from somewhere it must have got. Yes or no?
Yeah.
So when I am saying I am reacting sulfide with oxygen, what is going to happen, Ayush? That these 2 extra electrons, the red electrons, will be pulled by oxygen. So that sulfur, that oxygen, that sulfide will convert into neutral sulfur. And O will become minus 2 because O has gained those 2 electrons and sulfur has lost those 2 extra electrons. Do you understand? So we will say that, sulfide is oxidized to just sulfur. But if you have even
Yeah.
lots, so 99% sulfides will convert into sulfur. Do you understand my point? So whenever you get
Yeah.
to see any compound with the nascent oxygen, no matter where this oxygen is coming from, sulfide will always convert to sulfate, nitrite will always convert to nitrate, phosphite will always convert to phosphate, sulfide shall always convert to sulfur. Okay, 99%. 1% reaction, I will explain it to you. S minus 2 will convert into sulfate. Okay, I'll explain it to you how it basically works. But for now, just remember that 99% minus S minus 2 will convert into sulfur. Now you have a reaction. So, for example, if I give you Na2SO3 reacts with HNO3. So, you know that HNO3 on sitting gives you H2O, NO2, and that nascent oxygen comes here. And what is the name of this compound I used? This is sodium sulfite. So simply add one oxygen here and you will get Na2SO4. Increase one oxygen here. Do you understand?
Yeah. Okay.
If I give you NaNO2, this is the name is sodium nitrite. And when you add HNO3 to that, what do you get? HNO3 on sitting shall give you what? So for example, if we have NaNO2 plus HNO3 concentrated. So this is going to be sodium nitrite, right? So HNO3 on sitting will give you H2O plus nascent oxygen. Am I right? And that one
Yeah.
extra oxygen, the nascent oxygen that it is going to release, that will actually combine with NaNO2 because it is like this kind of scenario that in HNO3, NaNO2 is forming that oxygen and thereby that oxygen rather than coming out will combine with NaNO2. So it is going to convert
Yeah.
into NaNO3. Understood or not?
Yeah. Understood.
Right? So this is how you make the product. So here my final product here shall be NaNO3. Similarly, if I have my phosphite, if I give you K3PO3, potassium phosphite, if I have potassium phosphite along with concentrated HNO3. So you know the concentrated HNO3 shall give me what? H2O plus NO2.
H2 plus NO2.
And that nascent oxygen shall go here with PO3. So it is going to be
A3PO4.
C3PO4. So basically the side products are just changing. Rest everything is remaining same.
Yeah.
You understand? So these equations are very, very easy. Similarly, now understand if I say K2S, potassium sulfide. So when I'm giving you potassium sulfide, what exactly does that mean? You understand? So we have K plus 1 and S minus 2 basically. So you see that we have sulfur here. We have sulfide. You remember the case of sulfide? Sulfide has 6 electrons of its own and 2 extra electrons.
Yeah.
So no. So that basically means
Yeah.
what? That basically means what? That when you are adding concentrated HNO3 to this, so this is going to give you H2O plus NO2. And that nascent oxygen when comes here, it sees sulfide.
Yeah.
What is it going to do? It is going to take those extra electrons from sulfide. It is going to say that you are already rich in electrons. Give me those two electrons. So this sulfide becomes sulfur. And O becomes minus 2 and there is K plus in the beaker. So they will combine to form what? K2.
K2.
So
Okay.
the products formed would be H2O plus NO2 plus sulfur plus K2. And H2O shall combine with K2O to form. Tell me.
H2, K2, O2.
Hmm? KOH. It's metallic hydroxide. So KOH plus NO2 plus sulfur. Because any oxide will dissolve in water to form hydroxide. Yes or no?
Yeah.
So this is how the product shall be formed. Now, similarly, if I have this particular reaction, if I say, any doubts in this?
No.
Now, have a look right here. So if I give you Ki, So Ki plus concentrated HNO3. So obviously it is going to form H2O plus NO2. That is definitely there. Plus nascent oxygen is formed. Now what does that nascent oxygen does? It comes here and it forms K plus and I minus 1, isn't it? So when
Yeah.
it forms K plus and I minus 1 and there is nascent oxygen. So nascent oxygen is going to do what? Tell me. Nascent oxygen is again atomic number 8, configuration 2,6. And what about iodide? Iodide is basically belonging to group 17. So it already has 7 electrons like chlorine. 1, 2, 3, 4, 5, 6, 7. But this is iodide. That means what? That it has a cross. Do you understand? The extra electron it has.
Yeah.
So because if it has an
Yeah.
extra electron, what exactly does that mean? That means when it comes in contact with oxygen, oxygen is going to pull that extra electron. So two I negatives, 1, 2, 3, 4, 5, 6, 7, and that one extra electron that we have right here, this extra electron, that will also be given to oxygen. So O shall gain 2 electrons, so O shall become O minus 2, and both the I's shall become neutral. 1, 2, 3, 4, 5, 6, 7. And another I shall also become neutral. So 1, 2, 3, 4, 5, 6, 7. So when they combine, they form I2.
Okay. Yeah.
So I will say that I negative, 2I negative, when they combine with the nascent oxygen, they will form I2. And the oxygen, since it is gaining 2 electrons, it is going to become O minus 2. Do you understand my point?
Yeah.
Similarly, when 2Cl negative comes here, so imagine in place of I, it is Cl, because chlorine also has 7 valence electrons in its valence shell. 1, 2, 3, 4, 5, 6, 7. And we are writing chloride, that means it has 1 extra electron, which is why it is negative. 1, 2, 3, 4, 5, 6, 7, an extra electron, which is why it is negative. Are you understanding?
Yeah.
And when it is combining with nascent oxygen, it is going to form what? Chlorine plus O minus 2. Same with Br
Yeah.
negative, 2Br negative. Well, if it combines with nascent oxygen, it is going to form Br2 and O minus 2. So this is how oxygen behaves with all of these ions. So what should I write here as a product? That ma'am, when KO comes in contact with what? Ki. So I know that I negative and O is there. Do you understand?
Yeah.
So what exactly does that mean? That we have I negative and that I negative one shall combine with oxygen. You understand?
Yeah.
So it is going to form I2. So I should first of all take 2Ki, because then only 2Ki shall break into 2K plus and 2I negative.
Yeah.
So if you have this particular part, you understand. And then we are left with what? We are left with I negative. So is there. So 2K plus is there and there is one O minus 2, because this oxygen has done what? This oxygen has taken 2 extra electrons from iodide. So this is going
Yeah.
to form K2. You understand?
Yeah.
And
Understood.
that K2, if it dissolves in water, what it is going to form? It is going to dissolve in water and
Okay.
form KOH plus NO2 plus I2. So we have the reaction Ki plus HNO3 gives me this. That's how the reaction is. So it's not about Ki. It could be any compound. If I give you an acid Hi also, hydroiodic acid, and if I add it with concentrated HNO3, so you should be able to make the equations. You know that HNO3 on breaking down on its own will give you NO2 and water and
Yeah.
nascent oxygen. And that nascent oxygen will go to I negative, will borrow 2 electrons from 2Hi. So that I negative will become I2.
I2
And
and O2.
O will become O minus 2, and it is going to combine with H plus. So it is going to form water, which is already there. You understand? So I don't have to cram any equation. like that. It's just the method of understanding how you frame the equations.
Yeah.
So if I ask you to complete this equation HCl combining with concentrated H2SO4. Now, why am I saying concentrated H2SO4? Concentrated H2SO4 behaves in exactly the same manner. All you need to understand is that concentrated H2SO4 on sitting will give you H2O plus sulfur dioxide plus nascent oxygen, and rest everything remains the same. Just the way we learned all the reactions in the similar way, you can write it down. So, for example, if I've told you HCl and I have mixed this with concentrated H2SO4, so you know that H2SO4 shall give me H2O, shall give me SO2, and then there is this nascent oxygen. And what is H plus and Cl negative? That is what HCl is. So, this nascent oxygen, if it comes in contact with chloride, so this chloride shall do what? You tell me.
It will give the
So
electron.
2 HCl I would be needing, because then I would be having 2 Cl negative. So each of the chlorides would give extra electron. So this yellow one is going to be the extra electron. And we have one oxygen whose atomic number is 8, so its configuration is 2 6. So this one extra electron would be donated to the oxygen.
Yeah.
So what is going to happen? You tell me. O is going to become O minus 2, and the
O minus
Cl is going to become Cl and Cl. So Cl is going to become 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. So this is how it is going to be. So chlorine shall be
Yeah.
formed, and that oxygen O minus 2 is definitely going to be neutralized by 2H plus. So it is going to form H2O. So I don't have to write down H2O, H2O 2 times, so it is already there. Do you understand? So it's not
Yeah.
cramming up the equations, it's like understanding the basic part. Now, any equation, if I write it down for H2SO4, it would be exactly the same way. So carbon with concentrated H2SO4, nitrogen with concentrated H2SO4, Na2SO3 with concentrated H2SO4, NaNO3 with concentrated H2SO4, Na3PO3 with concentrated H2SO4, phosphorus with concentrated H2SO4. All the reactions are exactly the same. So here concentrated H2SO4 is acting as an oxidizing agent. I hope you're understanding.
Yeah.
So how does it form? It forms carbon dioxide plus SO2 plus water. So SO2 and water is given by H2SO4. And that nascent oxygen being combining with oxygen, you know now how it forms. It forms CO2. Similarly, concentrated H2SO4 on sitting shall give you SO2 and water. And that nascent oxygen goes to nitrogen. Now, when it goes to nitrogen, it is atomic number 7. So configuration is 2 5. So when concentration is 2 5 and it is combining with oxygen, so it is losing 5 electrons. So it becomes N plus 5, O minus 2. And thereby, what is going to happen? It is going to form N2O5. And when it is going to form
Yeah.
N2O5, what exactly does that mean? You tell me. It is going to combine with water. So you just join N2O5 with water. What do you think it will be formed? H2N2O6.
HNO5.
You take out 2 common, so it forms 2HNO3. So rather than writing down this, I'm going to write down the final equation as SO2 plus HNO3. So I would write down
Okay.
SO2 plus H2O, and then that nascent oxygen shall be given to Na2SO3, so that shall be Na2SO4.
Yeah.
If it is going to give me SO2 plus water, and that extra oxygen shall be given here, so it is going to form NaNO3. And concentrated H2SO4 is there, so it is going to form SO2 and water. And that extra oxygen shall be given here, so it is going to form Na3PO4. Then I'm going to give you SO2 plus water. And that extra oxygen shall go to phosphorus, so it is going to form H3PO4. I hope you remember that.
Yeah.
right? So this is how you're supposed to write down the equations. So it's not like something that you need to, cram up the equations. You can always do that. Similarly, you understand what do we have in right here? If I give you copper plus concentrated H2SO4, now we are learning the reaction with metals as well. You tell me now. So what exactly is happening? So it is going to definitely give me SO2 and water, no doubt on that. But since it is a metal, you know that metals can displace hydrogen also. So it is also going to form copper sulfate. Do you understand my point?
Yeah.
So this is how these reactions are basically formed, right? So for example, if I give you zinc plus concentrated H2SO4, so definitely SO2 is being formed and water is being formed and nascent oxygen is being formed, but it is also forming ZnSO4. Do you understand how the reactions are basically taking place?
Yeah.
So these are the methods of forming the reactions. All you need to just remember is that how is the nascent oxygen, you know, interacting with all the other elements that you're dipping in H2SO4 or HNO3.
Yeah. Okay.
So this is the concept. Now you see, for example, if I talk about the HNO3, the dilute HNO3. So when we are talking about dilute HNO3, what exactly is happening with dilute HNO3? You see, the dilute HNO3 releases all the reactions now shall remain same, but it is going to give me H2O and NO, nitric oxide, and then nascent oxygen. Okay, so rest all the reactions remains exactly the same. So if they ask you zinc plus dilute HNO3 and zinc plus concentrated HNO3, what shall change? The nascent oxygen shall form zinc oxide or zinc nitrate because it is going to act as an acid as well. Along with that NO and water. And here it is going to form zinc nitrate plus NO2 plus water. That's the difference. You understand?
Yeah.
So it's very simple then. Otherwise, nothing much in this.
Zinc nitrate is formed just by displacement. Yeah.
Yeah, yeah.
Okay.
So here it basically shows what? That HNO3 is acting as an acid as well. And it is also acting as an
Yeah.
oxidizing agent as well because NO2 is being produced. But
Okay.
let us
Yeah.
suppose if I write down a particular reaction where I say, you know, that concentrated H2SO4, if I just simply say that, zinc plus H2SO4, and I'm writing down the equation as ZnSO4 plus H2. Now I ask you the nature of H2SO4 here. How is it acting here? So you
Acid.
understand
Yeah.
that here ZnS H2SO4 is going to do what? Zinc plus H2SO4 shall give you ZnSO4 plus H2.
Yeah.
So here no SO2 is being produced. That means it is acting as an acid here only. Just as an acid here.
So how do we know when it will act like an acid and an oxidizing agent?
Whenever SO2 or NO2 is being produced along with whatever the other products, then it is an oxidizing agent as well.
Okay.
But if no SO2 is being produced, then definitely it is just an acid.
Okay.
Yeah. So here in this example, what is happening? It is acting, NO2 is being produced. So HNO3 is acting as a oxidizing agent as well.
Oxidizing agent.
But since the salt is also being formed, that means here it is acting as an acid as well. You understand?
Okay. Yeah.
Yeah. So this is how you are supposed to write down all the equations. Are you understanding my point?
Yeah.
Right? So this is how these equations have to be understood now. So that is why these equations you can now frame any number of equations using this method. The very first reaction, that is copper hydroxide with ammonium sulfate, that is a different reaction. You will have to learn it. There is no shortcut for that. Though there is a method, but you will not be able to understand it right now because that's grade 12th method. So, yeah.
Okay.
Yeah.